All right, boys and girls, welcome, welcome. We are now live, coming straight from the world of physics to your home. And the first question we have here for you today is a helicopter is rising at 5 meters per second. So let's draw a little helicopter here. Woo! There's my helicopter. And it's rising up, up at 5 meters per second. And that 5 meters per second is a constant velocity. Okay? In addition, the question says that after 2 seconds, so it drops a bag first, so a bag is dropped. A bag is dropped. Now, there is a hidden piece of information in that word, dropped, but we'll get back to that. And then it says after 2 seconds, delta t, 2 seconds, what is the bag's velocity? V final of the bag is what? Question mark. So let's see if we can try and figure out this problem here. One thing that is we have to assume is that this is on the Earth, so we know that the acceleration is equal to g, which is negative 9.8 meters per second squared. And we know that the initial velocity from the word dropped is equal to 0 meters per second. So this comes from there. And now we are looking for our final velocity. So let's see what equation we can use to find that. This one looks pretty good. V final equals AT plus VI. And if you'll notice, we have the time, that's 2 seconds, we have the A, and we have the initial velocity. Yes, we can use this equation to find the final velocity of the bag. So let's plug our numbers in. 9.8 meters per second squared times a time of 2 seconds. Oh, wait. Actually, I've made a mistake. And the mistake I've made is I've completely ignored this value here. Haha. Uh-oh. Oh, no. We've got a problem here. This is wrong. That's wrong. It is dropped. So even though it is dropped, we have to remember that the helicopter is moving up at 5 meters per second. So the bag is going to have the same velocity as the helicopter when it's dropped. So this is not 0. VI in this case equals 5, and a positive 5 at that, because it's going up. So we have to, we still have it, but we just have to put the correct value in. And now we need to get our trusty calculator and go 2 times 9.8 equals, that's a negative number, negative 19.6 plus 5 is going to equal negative 14.6. Let's do it here. Meters per second. Now we need some more room here, so let's kind of move this thing up a bit. So that's the answer to the first part. Question B says, or the question for part B is, how far has the bag fallen? So delta D equals question mark. In this case, we could try and use this equation. delta D equals 1/2 AT squared plus VIT. Let's see if that'll work. Then that's 1/2 A, which is negative 9.8. I'm just going to skip using the units for a second, or maybe I shouldn't skip them. And then T is 2 seconds. That's a squared. Plus VI, which was positive 5, times 2. And so that's going to give me, let's move this up a bit. Get our trusty calculator. 0.5 times 9.8 negative times 4, which is 2 squared, equals plus 10. And so the answer is negative 9.6 meters. And finally, part C. Part C is asking, how far below the helicopter is the bag? Haha, this is a good question. I like it. So this, I have to draw a diagram in order to explain what's going on here. I can't do this without drawing a diagram. So the helicopter is traveling up at 5 meters per second, and it's traveling at a constant speed, constant velocity. So I know how far the helicopter is going to go because the constant velocity equation is d equals vt. And so how far did the helicopter travel in those 2 seconds? No problem. It's 5 meters per second times 2 seconds, which makes 10 meters. So the helicopter in those 2 seconds went up by this much, 10 meters. But in the same time, the bag that was dropped, here's the bag, okay? The bag went down 9.6 meters. So the bag went this way, 9.6 meters, and the helicopter went up 10 meters. Obviously, you can see, therefore, that the distance between the bag and the helicopter, this 9.6 I got from question B. Therefore, you know that the answer is going to be, the distance between them is 10 plus 9.6, which is 19.6 meters. But that's the distance between the helicopter and the bag after 2 seconds. And that's the end of this problem. Thanks for watching. See you next time.